You know the saying, there are many fish in the sea. But only in the startup nation can brilliant minds take a deep dive into the desert.
Deep beneath the Negev's shifting red silence, something is breathing. It isn't a relic of the past, but a blueprint for a future we weren't supposed to have. Here, in a land defined by thirst, Israeli engineers have tapped into a 30,000-year-old secret, a fossil sea trapped in stone. They didn't just find water, they built a hidden engine of life. What they are pulling from the sand isn't just salt and scale, it's a revolution. One must first understand the tomb it was buried in to understand the harvest. The fossil sea, an archaeology of water. To grasp the magnitude of what lies beneath the dunes of the Arava, one must look past the shimmering heat waves and descend into the deep time of the Pleistocene. While the surface of the Negev is a scorched testament to aridity, it sits atop a geological anomaly, the Nubian sandstone aquifer. This is not a renewable reservoir replenished by seasonal rains. It is a fossil water source, a massive subterranean sponge containing runoff from a world that no longer exists. 30,000 years ago, during the Upper Paleolithic, the Earth's climate was a chaotic tapestry of shifting moisture. Torrential rains, fueled by a more temperate Mediterranean climate, fell upon the highlands and saturated the porous sandstone. Over millennia, this liquid was trapped by impermeable layers of shale and crystalline rock, sealed away as the region transformed from a verdant basin into a hyper-arid wasteland. This water has remained in total darkness for 30 millennia, pressurized and insulated, far removed from the modern hydrological cycle. It is a finite prehistoric resource, a liquid relic that has remained untapped largely because it is chemically difficult. Because this water has interacted with mineral-rich stone for eons, it is brackish, saturated with salts, sulfates, and magnesium that render it lethal to traditional terrestrial agriculture. To the untrained eye, discovering a salt-choked sea in the middle of a desert feels like a cruel irony. Water you cannot drink and cannot use to grow bread. However, the sheer volume of the reservoir is staggering. Some estimates suggest the aquifer contains hundreds of billions of cubic meters of water, spanning thousands of square miles beneath the Sinai and the Negev. For decades, hydrologists dismissed this poisoned well as an unusable ghost, a remnant of a dead era. But the Israeli approach was to stop viewing the salinity as a contamination and start viewing it as a curated environment. By drilling 800 meters into the crust, engineers began siphoning this ancient brine to the surface, creating an artificial sea in a place that has not seen a natural lake in geological memory. This extraction is more akin to mining than traditional well drilling. The water emerges from the earth at geothermal temperatures, often hovering around 37 to 40 degrees Celsius, carrying the thermal energy of the Earth's core alongside its prehistoric minerals. This heat is the first secret of the system. It provides a stable, year-round environment that ignores the desert's volatile surface temperatures, which can swing from freezing at night to blistering at noon. The engineers aren't just pumping water. They are harvesting an ancient climate, a steady-state ecosystem that exists independently of the sun. This is the radical pivot of the Negev project. Instead of fighting the desert's lack of water, they are colonizing the desert's hidden depths. They have effectively bypassed the surface world entirely, tapping into a subterranean graveyard to fuel a high-tech nursery for the future. It is a confrontation with the very limits of geography, proving that even a desert has a deep, wet heart if you are willing to dig through the layers of time to find it. The shock to experts wasn't that the water existed, it was that the Israelis had found a way to make the water's very defects its greatest assets. If the water is a ghost of the past, the creatures living in it are a marvel of the present. Osmotic alchemy, making salt a strength. The transition from geological exploration to biological alchemy begins with a single, counterintuitive realization. Salt is not an enemy of life, but a catalyst for it. To the uninitiated, the idea of desert seafood sounds like a surrealist joke. Yet the next phase of this subterranean system involves a process of osmotic adaptation that has rewritten the rulebook on aquaculture. This is Section 2, where the ancient, mineral-rich brine pumped from the Nubian sandstone aquifer meets the cutting edge of marine biology. When experts first descended into the Arava Valley to inspect these secret harvests, they expected to find stunted, struggling organisms. Instead, they discovered fish that were larger, tastier, and more resilient than their open ocean counterparts. The secret lies in the specific chemical signature of the fossil water, a cocktail of magnesium, calcium, and potassium that acts as a natural electrolyte bath for the species housed within the tanks. In standard aquaculture, fish must expend a significant portion of their metabolic energy on osmoregulation, the process of maintaining a constant internal salt balance against the external environment. In the hyper-controlled, brackish environment of the Negev tanks, the salinity levels are meticulously tuned to mimic the internal salinity of the fish's own blood. This creates a state of metabolic ease. Because the fish do not have to fight their environment to stay hydrated, they can redirect nearly all of their caloric intake toward growth and muscle development. The result is a growth rate that defies traditional biological timelines. But the shock to the international community wasn't just the speed of the harvest, it was the species themselves. Israeli scientists were successfully harvesting sea bream, dennet, barramundi, and tilapia in the middle of a sand-swept wasteland, hundreds of miles from the nearest coastline. The sea bream, in particular, provided a fascinating case study in adaptive resilience. Typically a Mediterranean saltwater species, the bream thrived in the desert brine because the fossil water is free from the pollutants, microplastics, and parasites that plague the modern ocean. The desert serves as a natural biosecurity barrier. There are no stray pathogens blowing across the dunes that can infect a tank of barramundi deep in a climate-controlled bunker. This allows for a clean harvest that requires zero antibiotics or chemical interventions, a feat that is virtually impossible in sea-caged aquaculture. Furthermore, the geothermal heat of the water, naturally rising from the earth at nearly 100 degrees Fahrenheit, means that the winter does not exist for these fish. They live in a perpetual, high-energy summer, feeding and growing at maximum capacity 365 days a year. This isn't just farming, it is an acceleration of evolution within a pressurized, mineral-rich womb. Beyond the food fish, the system produces a silent harvest that represents a multi-million-dollar niche, ornamental tropical fish. Species like the clownfish, native to the coral reefs of the Indo-Pacific, are now being mass-produced in the silence of the Negev. Experts were stunned to find that the colors of these desert-born tropical fish were more vibrant, and their survival rates during transport significantly higher than those caught in the wild or raised in coastal facilities. The mineral density of the 30,000-year-old water seems to enhance the iridescent pigments in the fish's scales, creating a premium aesthetic that has made Israel a dominant force in the global aquarium trade. This creates a bizarre juxtaposition. A person in a London apartment might be looking at a vibrant, oceanic creature that actually spent its entire life beneath a dune in the Middle East, swimming in water that hasn't seen the sun since the last ice age. The final element that truly unnerved the agricultural status quo was the flavor profile of the harvest. In traditional land-based fish farming, fish often develop a muddy or earthy aftertaste due to the presence of geosmin-producing bacteria in freshwater ponds. The brackish, mineral-heavy profile of the fossil aquifer completely eliminates this issue. The high magnesium content in particular acts as a natural flavor enhancer, giving the meat a sweetness and snap that is usually reserved for the highest-grade wild catches. When the first blind taste tests were conducted for European chefs, many refused to believe the fillets came from a desert. They were looking for the taste of the sea, but what they found was something better: the taste of a purified, ancient ocean. This realization shifted the narrative from survivalist farming to luxury production, proving that the desert isn't a place where life goes to die, but a place where life can be refined into its most potent form. By the time the harvest reaches the surface, it has already been shaped by tens of thousands of years of geological pressure and a decade of intense Israeli bioengineering. It is a product of hard sci-fi brought to life, a biological machine that runs on brine and heat. However, the fish are only the first chapter of this story. While the protein harvest is impressive, the system's true genius is found in what happens after the fish leave the water. The brine, now enriched with the organic byproducts of the fish's life, undergoes a second transformation, turning what should be waste into the most valuable liquid in the desert. The fish are merely the engines of a larger, more complex machine that breathes life into the very sand around them, creating a cycle that is as beautiful as it is efficient. Growth in the desert, however, requires a radical rethink of what we consider waste. The symbiotic loop, the machine in the garden. The true genius of the Israeli desert system lies not in the extraction of water, but in the radical repurposing of it. In a traditional industrial mindset, the waste produced by a massive biomass of fish, ammonia, nitrates, and phosphorus, is a pollutant that must be filtered, treated, and discarded at a high energy cost. In the Arava, however, the concept of waste has been conceptually deleted. The engineers recognize that the effluent from the fish tanks is not a byproduct to be managed, but a pre-mixed, high-potency organic fertilizer. This realization gave birth to the integrated biosystem, a closed-loop engine that functions with the cold, calculated efficiency of a spacecraft's life support module. Once the brackish water has passed through the fish tanks and absorbed the nitrogenous waste of the barramundi and tilapia, it is not returned to the earth. Instead, it is funneled into a sophisticated fertigation network that serves as the lifeblood for thousands of acres of desert orchards. This is where the secret takes on a mechanical beauty. In the nutrient-poor sands of the Negev, traditional chemical fertilizers are often washed away or fail to penetrate the root systems effectively. But the water coming from the fish tanks is different. It is charged water. The nitrogen is already broken down into a bioavailable form that plants can immediately absorb. As this nutrient-dense brine is dripped onto the roots of date palms, jojoba plants, and olive trees, it triggers a growth response that seems almost supernatural in an arid environment. The trees do not just grow, they thrive at a rate that outpaces those in Mediterranean climates. Experts were shocked to find that the olives grown in the desert using fish water had a significantly higher oil content and a more robust antioxidant profile. The salt in the water, which would kill most plants, acts as a positive stressor for certain desert-hardy crops, forcing the plants to produce more sugars and concentrated oils as a survival mechanism. The engineering required to maintain this delicate balance is immense. A series of computerized sensors monitors the chemical composition of the water in real time as it moves from the subterranean pumps to the fish and then to the fields. If the nitrate levels are too high for the fish, the flow to the orchards is increased. If the plants require a specific mineral boost, the fish feeding schedule is adjusted. It is a biological symphony where the animal and vegetable kingdoms are held in a state of artificial, high-tech equilibrium. This loop solves the two greatest problems of desert agriculture: the lack of water and the lack of fertile soil. By using the same gallon of water to produce both high-grade protein and high-value crops, the system doubles its water use efficiency, a metric that is becoming the gold standard for global food security. Furthermore, the system utilizes a cascading thermal model. The geothermal heat that keeps the fish active in the winter is also captured to warm greenhouses during the desert's frigid nights. By the time the water finally reaches the roots of a date palm, it has been stripped of its heat and its nutrients, leaving only the salt behind in the sand. Even this is managed through leaching techniques that prevent salt buildup, ensuring the land remains viable for generations. This isn't just a farm, it is a synthetic ecosystem, a machine in the garden that proves that humans can create life-sustaining loops in the most hostile environments imaginable. The shock for visiting scientists was not just seeing fish in the desert, but realizing that the desert was actually the ideal place to build such a system, because the lack of external biological variables allows for total, godlike control over the cycle. Yet, as surface temperatures climb, the real innovation is moving even further out of sight. Subterranean architecture, the brutalist farm. As the global climate paradigm shifts toward extreme volatility, the Israeli model has begun to evolve from surface-level tanks into a more radical, speculative form, the vertical, subterranean, brutalist farm. To the casual observer, the idea of moving agriculture underground seems like a retreat. But in the context of the Negev, it is a strategic masterstroke of thermal engineering. The surface of the desert is a theater of thermal violence, where temperatures can swing 50 degrees between high noon and midnight. By carving the secret fish system deeper into the earth, engineers have begun to utilize the crust itself as a massive natural heat sink. This is the transition from simple aquaculture to subterranean architecture, where the farm is no longer a building placed on the land, but a biological organ integrated into it. Experts who have toured the newer, experimental, deep farms describe them as feeling more like particle accelerators or high-security data centers than traditional agricultural sites. The architectural logic is rooted in the constant temperature zone. Once you descend approximately 5 to 10 meters below the surface, the Earth's temperature stabilizes, remaining largely unaffected by the sun's radiation. By housing the massive fish vats in reinforced concrete silos deep within the sandstone, the energy required to maintain the optimal 27 degrees Celsius for the fish is slashed to nearly zero. The Earth provides the insulation. The 30,000-year-old water provides the climate. This subterranean approach also solves the evaporation tax that plagues open-air desert farming. In a standard desert pond, millions of gallons of precious water are lost to the sky every year. In the sealed, brutalist chambers of the Negev's underground network, the humidity is recycled through advanced condensation captures, effectively creating an internal weather system that loses almost nothing to the outside world. It is a bunker for life, designed to withstand a planet that is increasingly becoming a desert itself. Beyond efficiency, this move underground represents a shift toward bio-industrial brutalism. These facilities are designed with a stark functionalist aesthetic: raw concrete, exposed piping, and high-pressure valves, creating an environment where biology is managed with the precision of chemistry. The shock for visiting experts in this section of the system is the sheer scale of the verticality. Imagine a silo 60 feet deep, filled with shimmering, mineral-rich brine, where thousands of barramundi swim in a perpetual artificial current. The water is oxygenated using micro-bubble technology that feels more like a laboratory experiment than a pond. This vertical stacking allows for a massive increase in protein production per square meter of land, effectively decoupling food production from the surface area. In this speculative but functioning reality, a few acres of desert can produce as much protein as a sprawling coastal fishery, all while remaining invisible to the satellites overhead. This subterranean shift also addresses a psychological barrier in modern agriculture: the hidden nature of the system. By placing the most vital resource, food, deep underground, it is protected from the sandstorms, flash floods, and locust swarms that have historically devastated Middle Eastern farming. It is the ultimate expression of human agency over an uncooperative landscape. The architecture is a statement that we no longer need the right environment to thrive. We can simply build one. As these facilities expand, they are being designed to incorporate living walls that use the ambient humidity of the fish silos to grow high-value mushrooms and microgreens in the dark, utilizing LED spectra tailored to maximize photosynthesis without a single ray of natural sunlight. It is a multi-layered, brutalist cathedral of consumption where every calorie is accounted for and every watt of heat is reused. The implications of this architectural pivot go far beyond the borders of Israel. By mastering the art of the subterranean farm, these engineers have created a template for hostile environment habitation. If you can grow premium sea bream and lush produce 100 feet beneath a burning desert, you have solved the fundamental problem of human survival in a resource-scarce future. The secret fish system is no longer just a clever way to use salt water. It has become a masterclass in defensive, sustainable architecture. It is a fortress of food, a concrete-lined promise that even if the surface becomes uninhabitable, the cycle of life will continue in the cool, pressurized silence of the earth. This isn't just about feeding a nation, it's a dress rehearsal for leaving the planet. The Martian Blueprint. Training for the Red Planet. If the secret fish system feels like a scene from a science fiction epic, it is because the Negev is no longer being treated as a terrestrial farm, but as a primary laboratory for the human colonization of Mars. The parallels between the Arava Valley and the Martian regolith are not merely cosmetic, they are structural. Mars is a world of hypersaline soils, extreme thermal fluctuations, and total dependence on closed-loop life support. In the Maktesh Ramon crater, just miles from these subterranean fish silos, the D-Mars analog station already hosts ramonauts, who live in isolation to simulate the psychological and physical rigors of the Red Planet. However, the most vital Martian technology isn't a spacesuit or a rover. It is the very aquaculture system that has turned 30,000-year-old brine into a food source. To colonize a world with no topsoil and no fresh water, one must master the art of extracting life from a mineral-rich void, and the Negev is currently the only place on Earth where this is happening at an industrial scale. Experts are increasingly looking at these desert fish silos as the biological batteries for future space colonies. On Mars, weight and volume are the ultimate constraints. You cannot transport 1,000 tons of frozen beef. You must bring a compact, self-replicating source of high-density protein. Fish are the perfect candidates. They provide essential omega-3 fatty acids and complete proteins while living in a medium, water, that also serves as a radiation shield. In a Martian bunker, a vertical fish tank like the ones in the Negev would serve multiple purposes. It produces food, it scrubs carbon dioxide from the air through integrated algae systems, and the thermal mass of the water helps regulate the habitat's temperature. The Israeli model of using brackish water to fertigate crops is the exact blueprint for Martian agriculture, where colonists will likely have to use melted permafrost brine to grow their vegetables. By proving that polluted water can be a catalyst for a lush ecosystem, Israel has solved the primary hurdle for off-world self-sufficiency. This speculative future was brought into sharp focus when Israeli food tech startups began collaborating with space agencies to test cultivated meat and desert aquaculture in microgravity environments. The shock for the scientific community was the realization that we don't need a Goldilocks planet to survive. We just need a closed loop. In the Negev, every drop of water is a data point, and every fish is a component in a life support machine. This level of extreme resource management is not a choice in the desert. It is a survival mandate, making the Arava the most accurate simulation of a Martian colony currently in operation. The subterranean brutalist farms mentioned earlier are, in effect, early prototypes for the lava tube habitats that scientists believe will house the first permanent human residents of the Red Planet. When we eventually look back at the first human settlement in the Jezero crater, The technology keeping those pioneers alive will likely be a direct descendant of the pipes, sensors, and fossil water pumps of the Negev. The secret system isn't just a way to feed a small nation in the Middle East. It is the opening chapter of humanity's expansion into the stars. We are learning how to live in the impossible, right here on Earth, so that when we arrive at a world that is truly dead, we will already know how to make it breathe. The desert has stopped being a barrier to our expansion and has become the training ground for our greatest leap forward. This isn't just about feeding a nation. It's a geopolitical ripple that changes the very meaning of sovereignty in an age of scarcity. How desert seafood changes the power balance in the Middle East. The geopolitical ripple, water as a weapon of peace. In the traditional calculus of Middle Eastern power, water has almost exclusively been framed as a zero-sum resource, a finite asset over which wars are sparked and treaties are broken. However, the emergence of the secret fish system and the broader mastery of brackish water technology have introduced a new, non-traditional variable into regional diplomacy. We are witnessing the birth of hydro-realism, where technical expertise in arid land survival becomes a primary currency of statecraft. For decades, Israel's neighbors viewed its agricultural prowess with a mix of envy and suspicion. Today, in an era of accelerating desertification, that suspicion is being replaced by a pragmatic, almost desperate, need for collaboration. The shock that reverberated through diplomatic circles wasn't just the sight of fish in the desert, but the realization that this technology could stabilize the most volatile borders on the planet by decoupling food security from rainfall. The most tangible expression of this shift can be found in the wake of the Abraham Accords and subsequent regional alignments. Nations like the United Arab Emirates and Bahrain, which face similar hyper-arid challenges, are not just importing Israeli fish, they are importing the entire Negev blueprint. This represents a fundamental shift in how sovereignty is maintained in the 21st century. If a nation can produce its own high-density protein and nutrient-rich produce using the useless brine beneath its own soil, it gains a level of strategic autonomy that was previously impossible. This shared technological interest has created a blue-green diplomatic channel that persists even when traditional political dialogues fail. In this context, the brackish water aquifer isn't just a geological feature. It is a platform for a new kind of functionalist peace, where the mutual need for survival overrides historical grievances. However, this ripple effect is not without its sharp edges. The secret system also highlights a stark technological asymmetry within the region. As Israel and its new partners build high-tech, climate-controlled fortresses of food, other areas, particularly the Palestinian territories and parts of Jordan, remain tethered to the traditional failing hydrological cycle. This creates a hydroschism, where the ability to manipulate 30,000-year-old water becomes a marker of regional status. Experts are increasingly warning that if this technology is not shared equitably, it could exacerbate existing tensions. The challenge for the next decade will be moving from hydro-realism to hydro-inclusion, ensuring that the ability to turn salt into life is not used as a lever of control, but as a tool for collective regional resilience. The weapon of peace is only effective if its benefits are felt on both sides of the fence. As the desert continues to expand globally, the geopolitical weight of the Negev's secret will only grow. We are entering an age where a country's strength is measured not just by its military hardware, but by its biotic sovereignty, its capacity to feed its people without relying on a stable climate. The Israeli fish tanks are a proof of concept for a world where geography is no longer destiny. By mastering the subterranean sea, they have created a model of prosperity that is independent of the sky. This realization is what truly shocked the experts. The discovery that in the most contested landscape on Earth, the most powerful tool for stability wasn't found in a treaty or a bunker, but in the pressurized silence of a prehistoric well. This isn't just about feeding a nation. It's a foray into a digital biological fusion, where the secret becomes an intelligent, self-correcting entity. Future tech, sensors, genetic tailoring of desert species, and automated harvests. The bio-digital frontier, AI-managed ecosystems. The final evolution of the Negev's secret is the dissolution of the boundary between biology and information technology. We are no longer discussing a farm, but a sentient agricultural machine. By 2026, the system has integrated precision aquaculture, giving the desert a digital nervous system. In these subterranean silos, the human element is superseded by AI-driven acoustic monitoring. By using hydrophones to listen to the sounds of the sea, researchers have decoded acoustic signatures of fish stress and feeding. An AI hears subtle changes in water vibration and adjusts nutrient loads in real time, reducing waste by 50% through mathematical precision. This digital oversight extends into the DNA of the harvest. Through genetic tailoring, CRISPR and genomic sequencing optimize species for the abyssal desert. Scientists are no longer just raising barramundi. They are refining them, identifying genes for osmotic tolerance to create designer cohorts programmed to thrive in 30,000-year-old brine. This surgical editing creates a proprietary library of desert-optimized life forms, biological intellectual property as valuable as oil. The hardware is equally radical, utilizing digital twins to run billions of what-if simulations. If a sensor 50 miles away detects a moisture drop, the AI instantly recalculates the ripple effect through the tanks and pumps, adjusting the ecosystem before a human can react. This automated harvest ensures the cycle never breaks, turning the desert into a self-correcting organism. Here, life is an equation. We have moved from being stewards of the land to being programmers of a living operating system. As these hubs network into a biogrid, they shift resources with the efficiency of a financial exchange. It is the final victory of the machine in the garden, proving that the best way to survive a hostile planet is to turn biology into data. The mirage, it seems, has finally become the reality. Hit subscribe if you like this video and see future uploads in the channel.